Not necessarily to 2 sig figs, because this number will get us more than 2 sig figs when we add, but we're rounding off to the ones place. 33 is a combination of those couple examples. It's going to involve multiplication or division and addition. So you have to watch your order of operations. If you can multiply and round to the least number of sig figs and then add, you go to the leftmost decimal place, the least precise, you got to watch that as you're performing the actual calculation.
So do you round after every calculation?
Typically we have you round at the end. This example will be pretty obvious regardless of how you do that. So when it comes to order of operations, you'd have to round as you go. Okay? But typically we wait until the end. And because usually we're not combining both. 34. How to write a small number in scientific notation. Oh my gosh, this should be easy. So what do we do if we want to write 0.000000123 grams in scientific notation? Wait. 1.23 times 10 to the negative 7. We're just moving our decimal this way. Oops, not that far. Moving our decimal that way. And the next question is going to ask you the same kind of thing, but about a big number. Alrighty. In 37, you are going to be dividing numbers in scientific notation. So I want to divide this 1.23 times 10 to the negative 7 by 2.0 times 10 to the third. Mathematically, what are we going to do here?
Next question.
I've got 3 more, and I'll be done. 1.23 divided by 2. And then what do we do with these exponents? Subtract the exponents. So is this going to become more negative or more positive? More negative, right? Negative 7 minus 3. Okay? 38 is asking about the graph of an inverse and a direct proportion. Okay, this was way at the end of the chapter notes. An inverse proportion is going to look either like this, or it could be a curve up, or like that. A direct proportion, of course, is going to be what? A straight line. So a direct proportion would be like that, or it could be decreasing too. Okay? For 39, you need to be able to write the proportionality equation for a direct and an inverse proportion. Okay? So, a direct proportion, density is an example of a direct proportion. Oh my goodness. D equals m over v. A mass divided by volume gives us a constant density. So, K equals, say, x over y. You might see it that way in general form. That is a direct proportion. Direct divide. Straight line in the graph. An inverse proportion, the constant would be x times y. That's the equation. Yep.
In the notes it says k equals y over x.
But that's fine. Just whether you're dividing or multiplying is more important. Okay? And for 39, this is going to be one of those questions, which of these is not true? Okay? So make sure you watch that. And 40, how to describe the relationships between the variables in a density equation. So I kind of just went over that. Density is a direct proportion. When mass goes up, volume goes up. If you have a bigger mass of the sample of that particular substance, then you also have a bigger volume, and vice versa. Okay.